Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we're going to talk about handling exceptions that occur within your application. And we'll discuss what can go wrong, why things go wrong, and how to build resilient applications that are impervious to crashes through the use of the try-catch block in C#. So when the compiler catches a data type mismatch, an unresolved reference to a class, or malformed C# instructions, it will refuse to compile your source code into a .NET assembly until you fix the problem. These types of problems are called compilation errors. However, there are other errors that happen during runtime, or in other words, happen when the compiled .NET assembly is executing. There's countless reasons why this could possibly occur, but many times occur due to situations that are somewhat outside of the control of the developer. For example, if your application can't read or write to disk because a folder or a file is missing, or it's corrupt, or the disk is full, or because network access to that resource is unavailable, or when attempting to access a database, a table is missing or otherwise unavailable, all of these would cause your application to experience an exception at runtime. Now, in some cases, the developer may have not foreseen a problem and therefore didn't account for it. For example, he allows users to type in a country code like USA or Canada, but the user misspells it or maliciously types in numbers instead of alpha characters. In which case, it could potentially crash your application if you're not, as a developer, trying to account for that possibility. So as a software developer, your job is to make sure that you account for these possibilities. A friend of mine once said that 80% of all code exists to solve 20% of potential problems that occur. Generally, software developers should be pessimistic of the reliability of all input outside of the program. Whether that's a file or a network resource, then you should treat it with great suspicion. If you're relying on a user to type in data into your application, then you should treat it as being evil. All right? This is the software developer's equivalent of defensive driving. You should be coding defensively. And the way a C# developer codes defensively is through the use of a try-catch block and some ingenuity on his part. So what I have here is the read text file while project from earlier when we were looking at the while loop iteration statement, while we were looking at how to open text files. And so what I want to do is just change values.txt, which we clearly have as part of our solution, and we've already instructed our application to copy that to our output directory. I'm going to change what the name is that our stream reader should be looking for. Just that one character difference. I'm going to run the application and watch the fireworks. Okay, and you can see that we get a file not found exception was unhandled. Now when we're running this in debug mode, we'll see a friendly little error message like this, created specifically for software developers. But what if we were to distribute this application? Let me go ahead and select Debug Build Solution, and let me open up and find the release version of our DLL and then double click it. And you can see this is what the user would see. It's quite an ugly scene here. Read text file has stopped working. Windows can check online for a solution. Oh, there's all kinds of confusion going on, and it shuts down the application. It's not a pretty sight, okay? That's what the user will see if we don't take some steps to safeguard ourselves against the possibility that exceptions can happen within our applications. So to fix this problem, let's do this. I'm going to add a try-catch block. So I'm going to open up with the keyword try. I'm going to wrap basically this whole thing around our application, and then I'm going to create a code block around all the code I already had in there, and I'm going to use the keyword try above it. Then below that first code block, I'm going to add a second code block with the keyword catch above it. Now inside here we can do something like console.writeLine, anything we want to do here, but let's just make it simple. We experienced a problem. Sorry, I don't know, maybe we could come up with a better error message than that, right? But let's go ahead and run the application now. And let's take this console.read line and put it below our catch statement. Rerun the application. All right, so you can see immediately we experience a problem. Sorry about that. All right, so we might want to provide a little more information about what the problem was. So what we can do is go back to our catch statement here, and what we want to do is catch an exception of We're going to call it E. So it's the data type is exception, and we're going to reference the exception with a variable called E. Then what I can do inside of here, let's comment this out and do something a little bit more helpful. All right, and then I'm going to go e.message. So the error object has a bunch of information, data, the message, the source of the problem, any inner exceptions and things of that nature, and we're not going to look at all of these for this video. We're just going to look at the message that's output. So now when we run the application and we have a problem, we experienced a problem, could not find the file. Well, that might be enough to help our user diagnose the problem on his own. But I think we can do a little bit better than this. If we were to look for the help online for the stream reader, it would give us a list of potential exceptions that are thrown by this class. So I happen to know that we can do something like this. And as I start to type, notice that it gives me some options here. File not found exception. Therefore, I can handle it a little more specifically. So now if we run the application, we'll get a more specific exception. So the exception class is a base class, and there are more specific, or rather there are classes derived from exception that we can check for, and these will be executed in the order in which we have them in our code. So we might start with the more specific possible problems, and then as we go through our catch statements, go to the highest level, which would be exception. So I could go to another one here, and we'll go directory not found exception E, and here we'll do a console.writeLine couldn't find the file. Are you sure that directory exists? And again, this error message may not be great, but what will happen is once we attempt to create an instance of StreamReader passing in values 1.txt, it's going to first start with the file not found exception. Does that match? If not, it'll try to match and see, is the exception I just experienced the directory not found exception? And if it doesn't match that, it'll go to the most general exception that we have listed here at the bottom of our list of exceptions. Okay, so to fire off this directory not found one, we might do something like this, and we run it, and now we will see couldn't find the file. Are you sure that the directory exists? Okay, I just made that up off the top of my head. All right, there's one other part to this try catch block, and that is a finally block. And the finally block will execute no matter what, whether this block of code succeeded or if it failed and went through one of the catch statements. So here you would, and let me just type this in, you would perform any cleanup to roll back the data or close connections to files or database and so on. Okay. So you might be wondering, when you start writing applications, why not just wrap the entire application in one big try catch block? Well, frankly, that's kind of a bit lazy. Some developers have done that, certainly, but they're often ostracized by their users for providing these cryptic error messages that no human, except maybe the guy who actually wrote them in the first place, even understands. So the reason developers do this is because sometimes they take that exact approach, leaving exception handling to the very end of the software development process. This leads to a catch-all that's convenient for the developer, but it's maddening for the user. So you should always strive to put the same amount of attention into protecting your user from having to guess at what to do next. If you can fix the problem without them even knowing it, then you should do that. If you can't, then identify the exact problem and then ask the user for input so that they know what they need to do next to help resolve the problem, and then you can go about handling that situation gracefully. You should protect the end user from losing data or from feeling dumb at all costs. That is what makes your application polished, and it's what end users expect, a reliable experience, no surprises. All right, so to recap, in this lesson we talked about defensive coding using the try-catch block to plan for the inevitable problems that come as a result of trusting anything that's exterior to our application. We talked about handling the special cases first and then following up with more general exceptions near the bottom of our catch statements. We also talked about the mindset of the conscientious developer who seeks to advocate and protect the end user from losing data or making tough choices or feeling dumb when they're using our application and they experience problems. Using a catch-all strategy is really not ideal, and you should strive to examine each part of your application that relies on exterior resources and then judiciously apply a try-catch block around those parts. All right, so we'll see you in the next video. Thank you.